Okay, so are you guys ready now? So just give me a thumbs up just to let me know that you guys are already ready. Okay, 1, 2, 3, 4, 5, 6. Right, so at least 70% of you. Well, anyway, so the others will just catch up to us. So from here, we can simplify this one a little bit more by distributing this 2 right here to our I sub 1 and I sub 2. So 28 minus 4 I sub 1, okay, minus 2 I sub 1 minus 2 I sub 2 is equal to 0. Wherein this one will become 28. So let's see, I1 and I1, so we have the same. So we have this one will become negative 6 I sub 1 and negative 2 I sub 2 is equal to 0. And this is 28. Okay, so that's it for the equation number 1 for the loop 1. Next one is 7 minus 12 I. This one is 12 I sub, this one is 1. Okay, 1 I sub 2. Okay, minus 2 I sub 2 minus 2 I sub 1 is equal to 0. And then in here we have 7 minus, so we have a negative 1 and then negative 2 for I sub 2. So this one will become negative 3 I sub 2 minus 2 I sub 1 is equal to 0. And then from here, you can actually already use those equations. So let me just arrange this one. You have negative 6 I sub 1 minus 2 I sub 2 is equal to negative 28. Okay, and then for the second equation, so we have here negative 2 I sub 1. So I'm just simply aligning them. So I sub 1 for I sub 1, and then I sub 2 for I sub 2, and then their voltages. Okay, so minus 3 I sub 2 is equal to negative 7. Okay, so just by having these two equations, then you can already use again your calculator to solve for the, yeah, I thought I was disconnected. Anyway, so from here we can use negative simultaneous equation, and then negative 6, negative 2, negative 28, and then negative 2 again, and then negative 3, and then negative 7. So for the I sub 1, so whichever the one that you've used as your unknown variable, that is the answer for that variable also, the first one. So I sub 1 is 5, and then the second one is equal to negative 1. So notice that we have negative sign again, so it's just that the assumed flow of current in here is actually should be the other way around. Okay, so instead of having a counterclockwise, this one will go clockwise, or the conventional method. All right, so let's see if we have the same result. So this is the equation number 1, I guess, and this is the equation number 2, and then from there you can use a simultaneous equation and use your calculator, and then you will get this one. Okay, so 5 amps for the I sub 1, and then negative 1 for the I sub 2. Okay, so are we clear so far on how did we get the results for I1 and I2? So just raise your hand if you have a question, or just give me a thumbs up if you were able to get it. Okay, so it seems that most of you were able to get this one. Anyway, so notice that, let me see, I think we've used the same example. 10, 120. No, it's not the same. All right. So anyway, the thing in here is if you're going to use mesh analysis, you're only going to have two equation. Okay, but if you're going to use the Kirchhoff's law, okay, in solving the I1 and I2 or I3, okay, so you'll come up with more equations. Okay, like let's go back here. So if we have this first loop, second loop, you're going to perform more loops on the outer side, and then you're going to have another equation which is for the KCL. So all in all, you're going to have, so let's say KVL, KVL, and KCL. So if you're going to do that one, all in all, you're going to have four loops. But if you're going to use mesh analysis, you're going to have two loops only. Okay, wherein you'll be able to solve the I1 and I2 right away instead of having a lot of equations. But of course, it will give you the same result. So yeah, that's the main point on why you're going to use mesh over KVL and KCL. Okay, so yeah, so we're drawing the circuit. We have this one at first, okay, which is -1 ampere. If you're going to correct this one, you're going to have this current now. So the flow of current is now clockwise. So 5 amps here and then 1 ampere. All right. Now, so you guys might be wondering, now what about the R sub 2? Okay, so we have a current. Let me just get this one. Okay, so we have the current for the I sub 1. Okay, and then for the I sub 3, let's say this is no, I sub 2. Okay, let's just call this one as your I sub 2. Okay, we have that current. But what about this path in here? Okay, what is our final current? Okay, so as you guys can see right here, we have a current that is flowing, okay, right here, and then we have another current that is flowing right here. So they are basically clashing with each other. Okay, it's like having a collision. So of course, whichever one is bigger, then that is the one that is going to win. Okay, so as you guys can see, we have 5 amps for the I1, and then we only have 1 amp for the I2. So for the for the final current of this one, or for the final flow, so we're going to have this flow of current right here. It's just that instead of having 5 amps here and then 1 amp here, this one now will become 4 amps. Okay, so 5 minus 1 amp. So basically just deduct the lesser current. Okay, and then follow the stronger current. Okay, so where is the explanation of that one? So yeah, the higher a flow of current wins. Okay, so the stronger the current will win. So 5 amps here, and then 1 amp here, and then 4 amps on this branch here. Okay, so yeah, that's it for this example. Are we clear with this one so far? Okay. So one thing that I would like you guys to know about this one is, just by applying actually, secretly you can apply KCL. Okay, because from here you can already solve the value of, this I3. Let's say this is your I3, and then this is your I1 and I2. So from there you can already solve the value of your I sub 3 here. But yeah, anyway, just by having the concept of KCL and KVL, you can check that one or verify that one if you have correct answer for this branch here. So yeah, let's have another explanation why mesh current analysis is much more better in solving a larger network. Okay, so as you guys can see right here, if I will copy this one and paste it right here and then draw all of their loops. Okay, so you will have one loop here, another loop here, another loop here, and then you can have another loop on the outer side, and then plus the KCL equation. Okay, so all in all, you're going to have 5 equations. Okay, but if you're going to deal with meshes only, okay, with mesh analysis, you're only going to have to deal with this loop, another loop right here, and then another loop right here. Wherein it will give you 3 equations only. Okay, so mind you guys, having 5 equations when it comes to solving for unknowns is super difficult. Okay, especially that the limit, okay, the limit of our calculator is up to 4 equations only. Okay, you cannot have 5 unknowns, 5 equations. So up to 4 unknowns only. Okay, so that is why in this example, it's much more preferable to use a mesh because it will only give us 3 equations than having 5 equations. Okay, so yeah, and what else? So those are just the label tables, and then here's the equations that you will come up with if you're going to use the Kirchhoff's law. So here is for the two current, so node 1 and node 2, and we have that 3 loops, loop right here, and then another loop right here, wherein you can again have another loop on the outer side, wherein all in all you can have 6 equations in total. Okay, which is super super difficult to solve. Unlike if you're going to apply mesh current analysis, you're only going to deal with I1, I2, and I3, which are those equations already. Okay, so of course less equations to work with is a decided advantage, especially when performing a simultaneous equation solution by hand without a calculator. Okay, so if you were forced by your instructor to solve this one without a calculator, so it's doable under mesh analysis. So it's also doable, it's also doable in branch current method or the Kirchhoff's law. But of course, it's much more time, tawag dito, it will require you a lot of time instead of, uh, doing the mesh analysis, and then you will be able to save a lot of time, okay, in solving the unknowns, I1, I2, and I3. Well, anyway, so yeah, that's it for the main advantage of the mesh current analysis. So are we clear so far up to this point? Hello, hello, you guys still around? So only Mr. Lawrence. How about the others? Were you guys able to get the idea on why use mesh over Kirchhoff's? But of course, one thing that I would like you guys to know is in your exam, okay, so if I ask you to, use the method uh, Kirchhoff's law only, then you should only use that method. Okay, that is the one that you should give me, okay, as a solution, and then give me your final answer. Okay, you cannot have another method like mesh current analysis to solve that uh, let's say question. Well, maybe you can perform that law or analysis, but just to check if you really get the correct answer or no. Okay, so yeah, and then we have here unbalanced Wheatstone bridge, which is again much more ideal for a mesh analysis, because if you're going to apply branch current method, you're going to have to come up with three unknown, I mean 6 unknowns, okay, and then 3 KCL loopings, okay. Unlike in mesh analysis, okay, you're only going to solve for all the currents and voltages with much fewer variables. So maybe instead of having 5, let's say 1, 2, 3, 4, 5, and 6 for the KCL. So yeah, 6 equation for the Kirchhoff's law. But if you're going to use mesh analysis, so you're only going to deal with 3 loops. So one right here, and then another one right here, and then another one right here. Okay, and then that's it. So at least half of the equation were already solved. So by drawing the mesh, of course, going to put here your first flow of current and then another flow of current. So it's completely up to you. Is it is it clockwise or is it counterclockwise? Either of those two, okay, is correct. Okay, it's just that if your assumption of your flow of current is incorrect, then it will give you a negative sign. Okay, but if it's correct, then it will give you a positive flow of current. Anyway, those are already for the first two assumption for the currents, and then for the third one we have this I3 right here. Okay, so yeah, those are the loops that we're going to deal with when it comes to solving for the I1, I2, and then I3. So in here we'll just put the labels or the signages: positive, negative, positive, negative. But notice that in here we have a clash of or different directions of your current. So we have going from here to there, and then we have current from here to there. Well, anyway, the same concept, whichever is a stronger current, and that is the one that will win. Okay, so let's solve this one. So let's come up with our own equation so that it's easier to you guys to understand. So let's do KVL first at loop 1. Okay, so let's start with R2. So we have here negative 50 times I1. And then we have here negative. Okay, so I get the sign where it's living, so it's always negative. So negative 150. Okay, so they have the same flow of current, so nevertheless of the sign. Okay, so you might get negative I1 and then negative I sub 3 in here, but it's not. Okay, so nevertheless of the signages, if they have the same flow of current, okay, so the one that you're going to write is the I sub 1 first, okay, and then plus I sub 3. Okay, so the one that is inside first before the outside. So it's always positive or it's always addition if they have the same flow of current. Okay, so that is the rule. Okay, so later on you will see what is the difference of this one and then this one. Anyway, so that's it for the R1. And then for the R3 we have minus 100, okay, times, so we have the I1 first. So again, they have the same flow of current, so the same signages. So I1 plus, oops, yeah, that's correct, I2. Okay, I1 and I2 is equal to 0. So this is already our first equation. So are we clear so far with our first equation? Okay, so again, just a reminder. So mostly this is where my student is getting, having an incorrect answer. So when it comes to current, okay, especially in mesh analysis, so the signages of your I1 and I3 will always be positive. Okay, so it's just that this positive right here uh, will vary if they have different flow of current. Okay, but if they have the same, then this one will be always positive. So if it's having a contradicting flow of current like this one, just change this one into negative. Okay, and also the one that you're going to write first is of course the inner current before the outside current. Okay, so that's how we write the arrangement and then the signages of currents in here. Okay, anyway, that's it for the equation number 1. So let's now go over with the equation number 2 for the I2. So let's start with R5 first. So we have positive, my bad. Okay, so we have this flow of current. Okay, so let's go over. with this one first, just to follow this flow of current. Okay, we have clockwise. So the leading part is negative. So negative 300. Okay, times. Okay, so we have here I2 first. I2 first, and then followed by another flow of current, which is I3. So notice that we have different flow of current or direction of current. So we're going to put here negative. Negative I3. Okay, so moving on, we have here a negative 100. Okay, times, so they have the same flow of current, so I2 plus I1. And then lastly, we have here negative 250 times I sub 2. There you go. Oops. Okay, this is now our equation number 2. So are we clear so far? KVL at loop 1 and loop 2. So were you guys able to follow? And how did we get this equation number 2? So let me just check, so that we can go back to that part again on how did we come up with this I2 minus I3, so on and so forth. What about the others? Mr. John David, Mr. Kenji, Mr. Ryan, Mr. Jasper, Mr. Lawrence, Ms. Paklauna, Mr. Bradley, Mr. Zosimo, Ms. Maxine. All right, so maybe half of you were able to get this one. Anyway, let's now move on to the equation number 3. So let's start with the R4 first. So we have here positive, okay, as our leaving signage. So positive 300, okay, and then the current on the inner side first, which is I3. And then again, notice that we have different flow of current in here. So we have here negative I sub 2, okay. And then the next one is positive 150 I3 first, followed by the I1. So we have the same flow of current, so it's positive in here, positive I sub 1. And then going back here, so we have negative 24 is equal to 0. So this is now your equation number 3. Okay, and then from here you can actually simplify this one, just by distributing this negative 150 I sub 1 and I2 I sub 3, the same with negative 100. So to do this one, okay, I think it's easier if we're going to do this one in Notepad, since it's harder to draw in Paint. Anyway, for the equation number 1, okay, so in here we have negative 50 I sub 1 minus 150 I sub 1 minus 150 I sub 3 minus 100 I sub 1 minus 100 I sub 2 is equal to 0. Okay, so we can simplify this one a little bit more by combining similar terms. So notice that we have 3 I sub 1 in here, negative 100, negative 150, and then negative 50. So all in all, we'll have negative 300 I sub 1. So just let me know if I made a mistake. And then I sub 2 is negative 100 I sub 2. And then negative 150 I sub 3 is equal to 0. So this is now our final simplified equation for equation number 1. Okay? About, let me put it right here. And then for the equation number 2, so we have here negative 300 I sub 2. And then positive. So negative times negative is positive. So positive 300 I sub 3. And then negative 100 I sub 2 negative 100 I sub 1 minus negative minus 250 I sub 2 is equal to 0. Then again, we can simplify this one a little bit more by combining similar terms. So can you guys still follow up to this point? Okay, what about the others? Are we still clear? Medyo po. Okay, coming from Miss Maxine. All right, so maybe at least 3 or 4 of you were able to get it. Anyway, so I recommend you guys to just reread, rewatch the video, okay, and yeah, just for you to be able to follow up to this point. Anyway, so from here we have negative. So again, just combine similar terms. So we have 3 I sub 2. So negative 300 plus negative 100 is negative 400 plus negative 250 is negative 650. Negative 650 I sub 2. Okay, so let me just move this one. I wanted to put here the I1 first. So we can have a better arrangement. I1, I2, and then followed by the I3. Alright, so the next one is I3, which is positive I sub 3 is equal to 0. Okay, that's it for the equation number 2. And then for the last equation, so we have here 300 I sub 3 minus 300 I sub 2 plus 150 I sub 3 plus 150 I sub 1 minus 24 is equal to 0. Okay, so I guess we can still simplify this one. So from here, so next 300 plus 150 is 450 I sub 3 minus 300 I sub, okay, so let me put here the I sub 1 first. 150 I sub 1. And then let me transfer this one on the other side. Okay. 300 I sub 2 plus 450 I sub 3 minus 24 is equal to 0. Okay, so those are now the simplified, okay, equations of our equation 1, 2, and then 3. So the next thing that we can do is compare whether we have the same equations. So let me see. So I guess this is the equation number 1. So 300 I sub 1 minus 100 I sub 2 minus 150 I sub 3. Why do we have different signages? Okay, let me just check. 50 I sub 1 plus 100 plus 150. Yeah, everything's correct. But in our case, what we did is negative 50, negative, negative. So everything's negative. How come that this one isn't? My bad. I wasn't able to put the negative sign. Okay. So negative 50, negative 150, and then negative 100. Okay. So a total of negative 300. All right. So let's compare it again. So in here, everything is negative, but in here, everything is positive, which is just the same, just the signages. Okay. We can multiply this one by negative to have the same equation. And then for the equation number 2, so we have positive 300 I sub 1. Oops, is this the second equation? 50. This one is still the first equation. My bad. And this one now is the second equation. Yeah, so negative 100 I sub 1, 650, and then 300. Okay, so in here, everything's just the opposite of the signages. So just multiply this one by negative, and then you will have the same signages for this one. Okay, and then for the last equation, okay, which is this one. So we have 150, 300, and then 450. Okay, so again, just multiply this one by negative, and then you will get the same result as this one. Okay, so it just this one was just transferred on the right side equation. And then from here, you can now solve this one using a calculator. Okay, and then you will get negative 0.09, 0.08, and then 0.14 for this equation. Okay, and then again, here is the reference for this mesh analysis, or for this uh, PowerPoint. So yeah, and then another conclusion or summary. So as well as using mesh current analysis, we can also use node analysis, which we're going to discuss later on. Okay, but not for today. So yeah, that's it for the mesh current analysis. So another reference, and yeah, that's it. So were you guys able to follow up to this point? Okay, so notice that there's a lot of explanations, blah blah blah, etc etc. Okay, and how did they come up with these equations? So yeah, just read those again if you wasn't able to follow our simple solution in here. Okay, because the explanation was done by my talking already, and then we just come up with these three equations right here. Okay, and then yeah, just by using your calculator, you'll be able to solve. Where is that one again? This one. Okay, those values. So yeah, that's it for this presentation. And then just a reminder, you're going to have a quiz on Kirchhoff's law and then Maxwell. So the due date of those two uh, is on May 24, 11:59 p.m. But I suggest you guys to finish this one first before finishing the Maxwell. Okay. And next meeting, we will discuss two modules, which is the superposition theorem and then the voltage analysis. Okay, or the nodal voltage analysis. Okay, let me just change this one. And notice that we don't have a quiz for this module anymore, module 5 and module 6, because we don't have enough time anymore. Because after May 24, you're going to have your exam already, okay, on those following day. So yeah, maybe your quiz will be just will be a very big part of your midterm exam. So yeah, that's it for week number 2. I mean week number 2, module 3 and 4, because we're not yet done for the module 5. So yeah, any concern so far or clarification? So how about giving me a thumbs up if it's already clear? All right, so to those who keep,
Clarification.
ano yan? Mr. Awas?
May, paano sir kapag negative yung final answer, gagawin na lang positive sir?
Yeah, just make it positive. Okay. Yun nga pala, bago bago tayo magkatalo sa final answer nyo. If you have a negative answer, just make it positive. Okay? Well, we'll see. Kasi hindi ko sure kung ginawa kong positive lahat yung answer nyo dito. Okay, sa Kirchhoff's and Maxwell. But most probably, your final answer will always be positive. Okay, however, if everything is negative, consult me first. Okay, you can ask me at that time, and then I will check if the one that you should put is positive or negative. So yeah, mostly. Okay, so later on, I will check, okay, kung ano nga ba yung mga final answers dito. So I will announce. Okay, I will announce later if it's everything is positive or if everything is the same with whatever you have. If it's positive, positive. If it's negative, negative. Okay. So I will clarify things later on. So hindi ko kasi mapakita dito. Syempre makikita nyo na yung magiging quiz nyo. Okay. Any other concerns so far? How about in your first quiz? Have you guys encountered the problem? So I think none naman kasi I think most of you were able to, get at least 60% to 90%. Yeah. So no one got a perfect score. Oops. Marami pa lang hindi nag-take. Oh, reminder guys, the due date of your first quiz will be today, 11:59. So make sure to finish this one already. Okay? So parang 4 pa lang yating nag-take. Anyway, any other concerns that you guys would like to ask? So to those who gave me a thumbs up a while ago, so you guys may now go. And let's just meet again next meeting. Okay, so that's good. Mr. Awas. How about the others? Who's not giving a feedback? Okay, so if you already gave me a thumbs up, then you guys may now go. And for the others,
Bye, sir.
goodbye. Okay, good. How about you, Mr. Labsan?
Sir, may question ako.
Ano yan?
Dun sa pag-answer, sir, kasi hindi ako sure kung yung dapat bang ilagay ko sa papel ko is yung 2 decimal places lang tapos doon ko na diretso yung calculations. Parang every time 2 decimal places or parang
Yeah.
diretso na. Kasi minsan, sir, parang may mga deviation yung sagot eh.
It's okay actually. Hindi ko lang kung ikaw yung sinagot ko dati, pero meron akong sinet na margin error. Okay, so okay lang na ang sinagot mo is 12, let's say 12.01. Pero ang sinagot mo lang doon is 12 let's say 12 lang, hindi mo na sinama yung 0.01. Accepted pa rin 'yon. Okay, may nilagay akong margin of error doon. Kaya kahit magkakaiba kayo 12.01, 2, 12.015,